Hello everybody, I'm Roman Rodriguez and we are on chapter 10, heat, and we are doing, this is lesson 2, okay? And as you know, we are doing linear thermal expansion of solid, and in my previous lesson I had derived this equation of coefficient of linear expansion, which is equals to change in length upon original length into change in temperature. So then we derived this final length is equals to initial length or the original length times 1 plus alpha, which is the coefficient of linear expansion, times change in temperature, that is T2 minus T1. Today, using this formula, I will be solving this problem which is in your textbook on page 206. The first numerical, 10.1 data. Now it says here that a metal rod of diameter 1 centimeter, so diameter is equals to B is diameter 1 centimeter, measures 50 centimeters in length. That means the original length or L1 is 50 centimeters. At 20 degrees centigrade, initial temperature T1 is 20 degrees centigrade. When it is heated to 95 degrees centigrade, when T2 is 95 degrees centigrade, that is the final temperature, its length becomes 50.06. So L2 is 50.06 centimeters. Now, what is the coefficient of linear expansion of the rod? Alpha, coefficient of linear expansion of this metal rod is equal to how much? Let's say this is part A, because this question has got two parts. The second thing that you need to find out is what will be its length, that is L2 is equal to how much when it is cooled to 0 degrees centigrade, when the final temperature T2 is 0 degrees centigrade. Okay, obviously it will reduce because on heating it expands and on cooling it contracts. Now let's begin. So as I said, we'll be using this formula. L2 is equals to L1 into 1 plus alpha T2 minus T1. So final length is known to us, that is 50.06. Initial length is 50. 1 plus coefficient of linear expansion we need to find out. T2 minus T1 is 95 minus 20. 95 minus 20 degrees Celsius. So this will give us 50.06 equals to 50 times 1 will give 50 plus 50 times alpha. 95 minus 20 would give you 75 times 50. You're multiplying it by this into alpha. So let's bring this 50 over here. 50.06 minus 50 is equals to 75 times 50 would give you 0, 5, 5 is 25, 5, 7 is 3750 alpha. When you subtract 50 from 50.06, you get 0.06. Let's move this over here. Divided by 3750 is equals to alpha. Coefficient of linear expansion. So on shifting this decimal 1, 2 places, we put 2 zeros over here. So you get 6 upon 375. And this 1000, when you take it on top, it will become 10 to the power minus 3. 3 2s are 3 1s are 3, 3 2s are 6, 7, 3 5s are 15. So what do you get when you divide 125 by 2? 2 divided by 125. So this will not go to the 0, not go to the 0. 2, 3 2s are 6, 3 1s are 3. 6, 7, 3, 7, so 125 divided by 125 will go to this how many times? 1 times 125, 5, and then you have to put 10. This will become 10 minus 2, 8. Have I got it right? 3 2s are 6, 3 1s are 3, 3 2s are 6, 7, 3 5s are 15, 2 divided by 125. And then you get, let me just do it again. Okay. 2 divided by 125. 2 will not go to the 0. And then we put another 0, 0. 1 to 1, 125. 5, 5, 10. 2, 3, and 7. 10, 7, 10, 7, 8, 9, 10. Another 0 over here. 6, 6 5s are 30. 12, 15, 6, 7. Very good. Point alpha is equals to 0.016 times 10 to the power of minus 3, or alpha is equals to 1, 2, 3. Shift resistance is 16 into 10 is power of minus 3 times 10 is power of minus 3. So you get alpha is equals to 16 times 10 is power of minus 6. 16 into 10 is power of minus 6 per degree centigrade. Okay. This is okay. Or you can write it down as coefficient of linear expansion is 1.6 times 10 is power of minus 5 inverse degrees centigrade. Right? So there we are. So this is the coefficient of linear expansion of that metallic rod. Okay. If you compare it to the ones which I have given over here, its rate of expansion will be less than that of aluminum, copper, but it will be more as compared to steel. Okay, whatever the metal rod is. Now let's move on to the second part of this question. You have to find the final length L2. Okay, let me just do it over here. L2 is equals to how much? When it is cooled to 0 degrees centigrade. So we now know the coefficient of linear expansion of this rod. So let's say we have to find the original length or the final length. The original length we already know is 50. Let me just put the formula first. L2 is equals to L1 into 1 plus alpha T2 minus T1. So L2 is what you have to find out. Okay. And original length is 50 centimeters, as you can see over there, into 1 plus coefficient of linear expansion we know is 1, 6 times 10 is power of minus 6, and T2 minus T1. What is the final length? The initial temperature was 20, and final is 0 degrees centigrade. Okay, so T2 minus T1, so 0 minus 20. So L2 is equals to 50 into 1 plus and minus, this into 0 will give you 0, plus and minus is minus, 20 times 16 times 10 is power of minus 6. So final length is the 50, 1 is 50 minus 50 multiplied by 20 would give you 5 2s are 10, 100, 2s are 10, and we have 1, 2, 2 zeros times 16 into 10 is power of minus 6. Right? I'll rewrite it over here. So we have L2 is equals to 50 minus 16 into 16 into 100, 1000 can be written down as 10 to the power of 3 into 10 to the power of minus 6. So L2 is equals to 50 minus 16 into 10 is power of minus 3. Or I can write it down as L2 is equals to 50 minus 16. We'll have to shift 1, 2, 3 zeros here. So L2 is equals to 50 minus 0.016. And what do you get when you subtract 0.016 from 50? This will give you 4, 8, 7, 10, 9.49. Right? So final length of the rod will be 49.984 centimeters. 10, 8 times 10. Right. So there we are. So as you can see, upon cooling, when you bring down the temperature to 0 degrees centigrade, the expansion doesn't take place, instead contraction takes place on the metal rod. Its size reduces from 50 centimeter to 49.984. I hope it is clear to you all. Hope to see you next time. Till then, take care.